So, good morning. The first thing that I want to talk about is homework. So far, I just graded the homework that you guys that was due yesterday. A handful of people did not do it, um, or only spent about 4 minutes on it. So I can tell the time that you guys are on, and I can see who has and hasn't done it. I promise you guys that first one is not going to. The first one's not going to kill your grade, but make sure that you're doing your homework and you guys are sticking with it. So we talked about when you guys were getting on some of the pros and cons. So one of the things is I'm not there to help you guys get started right away. And it's too easy to just kind of go through the motions with all your class and not really get into it. Okay. So please, please, please make sure that you guys are doing your homework. If I give you 10 or 15 minutes at the end of class, do it. Do it as soon as you guys get off. And I know you guys are probably tired. Um, but your homework is 100% of your grade until further notice. So not turning in one or two homeworks can literally crush your grade. So make sure, and I think it's still open. It counts late, but if you did not do it, go ahead and do it tonight because you're not going to have an assignment tonight. All right. With that said, there's a couple things that I want to clear up. So I know that people had questions on the homework from last night. So let's see. For instance, number 7. Give me just a second here. These are going to be your notes for tonight. And I said no homework. You don't have any assignment. I just want to make sure that you guys all get this. Number 7 on your homework looked like this. So 4, 5, 6, 7. It said this. F of x equals the absolute value of x. And then it said a reflection in the y. So reflection in y-axis. And it said followed by a translation, then a translation 3 right. Now, what I was looking for, that hopefully you guys did, what I was looking for was anytime you see a reflection in the y-axis, all that means is your coefficient is in the front. And then I want 3 to the right. So really, that's what I taught you guys. The problem is, so if you got that, that's good. I will go through and count it correctly. One of the things I hate about online learning is that there's a lot of things that I just kind of introduced that we haven't had time, or the in class. There's a lot of little examples that I haven't been able to show you. If your reflection in the y-axis comes first, and a lot of you probably said, I did this and it kept saying it was wrong. Well, what a reflection in the y-axis does, a reflection in the y-axis, and I'm going to go ahead and draw this up. You don't have to write this down, but I want to make sure that you understand what it does and what it is. So a reflection in the y and I'm doing the absolute value. A reflection in the y means that this is like a mirror. Your y-axis is a mirror. So each point over here, for instance, if I call this point right here A, then my other point has to be here. So if I'm reflecting it right away, it's the exact same graph. I never took the time to fully explain that. So if you missed it, again, I'm going to go ahead and give everybody a couple fluff points on this, but I just wanted to clarify. So this is y equals the absolute value of x. That's what they look like. So if you're doing a reflection, it's the exact same value. So if you're doing the reflection in the y first, it actually doesn't change. There's no need to put this. While this is technically correct, you don't even need this. A quick explanation of why is because whether I plug in a positive or a negative x, it's still going to always come out to be positive. So these two have the exact same graph. Now, with that said, Your final answer, and the only one that the book took, was this. Because it wanted the reflection first, I didn't need the negative because it is the same graph. And then if I'm just going to move it right, if it's followed by it right, then this is it. The thing is, if we were trying to map this out and do this, all of a sudden, this would be incorrect. All right. You don't really need to know the ins and outs of that yet. It will be fully explained. Like I said, one of the things I don't like about the start of this book is it just gives us a lot of partial information and it doesn't really connect to much that you've already done. I just want to explain why this is not right and why this is the only answer the book accepted. Okay? 100%. If you wrote this, I'm going to go back and look at your answers. If this is what you wrote, I will count that absolutely right because that's what I taught you. I just didn't get a chance to go in further detail. Okay. Now, here's your notes for today. Hopefully you finished your homework from last night. Again, I'm going to put in a couple of fluff points. It was out of 13. So I will make sure that everybody gets at least a 2-point bump on that. I'm not trying to crush your grade. If you haven't done it, again, I'm going to excuse your late homework for tonight. So if you have not done it for tonight and the other day. So if you haven't finished those, get those done tonight. So let's move on to today's lesson. Today's lesson is linear modeling. And why this is your objective, I really want you to be able to do this tomorrow. So I'm going to show you what we're doing in the long, and we're going to spend 3 days on this. So this is all stuff you did in Algebra 1. Where we're going to get to is stuff like this. All right. We're not talking about any of this today, but we're comparing equations with tables, equations with graphs, and we're making graphs with data. Now, the reason I'm showing you this first is because we're going to do the calculator stuff on Monday. So if you do not have a calculator, I think I asked this class to do it yesterday. If you do not have a calculator, go get one. If you can't, if you don't think that you can get one, please privately chat me or email me. So we've had a couple parents mention things like maybe they would buy one if somebody had. I don't want to say too much, but if you think that getting a calculator is something that you will not be able to do, we might have some avenues here to get you one. Okay, so privately chat me or send me an email. Now, take a second real quick. Let me get rid of that. Hold on. My computer's frozen. Take a second. This is going to serve as a warm-up. Again, you do not have an assignment tonight, but I want to make sure that you understand exactly how to graph this. So we're going to take off all the fluff, all the frills here, and the heart of this lesson is these two things. A, can you graph this? Do you know exactly what this looks like? And can you write this equation? If you can do those two things, the last 2 days have been successful. So I'm going to be quiet here and give you guys about 2 minutes to make sure that you know how to graph it and you know how to write the equation. About one more minute. Again, one of my hopes, obviously I'm not making it mandatory, is that you guys have like some graph paper that you're doing this. Even if you don't have graph paper, whatever paper, try and graph this. And at the very least, if you forgot a notebook next to you, hopefully you're looking at this and you can visualize this. Because like a lot of you guys, math looks really complex. It's really confusing until you start seeing this equation as information instead of anything else. About 10 more seconds here. Okay, so the vertex, can I get a volunteer here? And I want to go kind of quick here. Can I get a volunteer to tell me where is the vertex of this graph going to be?
-2, 3.
That's exactly right. So -2, 3. So asking what the vertex is basically saying, how has this been moved left, right, up, down, whatever. So it's always the opposite of what's happening to x, k. So -2, 1, 2, 3, that's my vertex. Now somebody else, just, do I know that this is going to open up or is it going to open down, and why? So give me a different volunteer.
It opens down.
That's exactly right. Why did you say it opens down? How do you know it opens down?
The slope is -1/2, so that
That's
means
right.
it opens down.
Yeah, and I keep calling it the slope. It's not really the slope, but it kind of acts the same. Because this is negative, that means it has to open down, okay? I'm not upset with how you say it because I keep calling it a slope also. But your A value is negative, so I know it has to open down. And at what rate does it open down? It goes down 1/2, but absolute values make V's. Down 1/2. So make sure that whenever you're graphing an absolute value, it's making a V. So would I say that that's been stretched or shrunk? Different volunteer. Well, sorry, what'd you say?
Stretched.
Stretched. Did I have somebody to either verify that or question that? So somebody said stretched. Does anybody else think stretched or shrunk?
I think it's shrunk because the A is less than 1.
So yeah, and that's exactly right. So this is actually a shrink instead of a stretch. So the negative just tells me how it opens up or down. And then this part right here, I can ignore the negative because that's less than 1. It's been shrunk. All right, and that's it. Any questions about that? Okay. Number 2. So I want you to write the equation with the given parent function. By the way, we will talk a lot more about functions later, but I had somebody question this morning and say, man, I think I'm in over my head. You keep talking about functions. I don't even know what a function is. For all intensive purposes, now this is not math talk. This is just me being plain and simple as much as I can. When I'm talking about functions as of right now, I'm talking about this is your most basic equation that we're working with. All right, we will talk about functions, but to each, the definition of a function is each input has exactly one output. That's not really important for right now, but somebody is getting bogged down in the word function, and don't let that bother you. So here's my basic function, my basic equation, and if I want to translate it right 5 first, and I'm just going to do this with you, my first step would be this. Right 5, it goes in as the opposite. Then up 2. Now here's the part, if you made a mistake, most people got that right. If you made a mistake, here's the part that most people forget. When you are following it with a vertical stretch or a shrink, or a reflection, you are multiplying everything by that factor. So what my entire answer should look like, you can never, ever, ever distribute inside an absolute value. So it gets multiplied to the absolute value, and it gets multiplied to the whole number. So anytime you are following it by a stretch or a shrink, you have to multiply both the absolute value and what's on the outside by that. Most people that missed it would just put the 3 there, and they'd kind of keep it like this. If you don't distribute it, it's wrong. Now, that is the heart of what we've done for the last couple of days. Any questions? All right. Well, guys, let's take a big step back. I do think that most of you are doing a really nice job. We're going to take a step back to something more comfortable. You've literally been doing this since like 7th grade or 8th grade. But just because you've been doing it for the last 5 or 6 years, you still, in geometry, you barely talked about this. So you don't even have to necessarily write all of this down. Yeah, Caden, we'll talk after class. Okay. So just to understand that the slope that measures the steepness of a line. So now we're going back to linear equations for right now, and we're just finding the slope of the line. So this is the equation, this is the math that we're going to do. So I don't know why they chose M for slope, but M stands for your slope, and it is the difference of the y's over the difference of the x's. Your slope is always a fraction. Now, this is how you've learned it. Or they also call it the change in y over the change in x. As we get into higher level math, and this is your first higher level math class, this triangle, whenever you see a triangle, especially in algebra, that means change. So as you guys get on to higher classes, when you go to pre-cal and when you go to college, they'll call it delta y over delta x. It's a Greek letter, and it just stands for change. Things to remember: positive slopes, we always go from left to right, so positive slopes go up and to the right. Negative slopes start from left to right, negative slopes are falling. If it is horizontal, I'm going this way, there's no up and down at all, your slope is 0. That means it's not changing. And an undefined slope is if it goes straight up and down. The best way to remember that is left and right is 0, up and down. If I just use the first one, up and down is undefined. So up and down. That was an N. I should use my pen. So up and down is undefined. I see a few people writing here, so I'll wait a second to go on. Now, a lot of people ask about slope y2 minus y1 over x2 minus x1. So that confuses a lot of people. I'll leave this up here. I'm going to change pages real quick. If I'm going too fast, if you guys are writing some of this stuff down, just stop me. I think that the notes, I think I already posted all of the notes online last night. I'll check again. I try and post the notes for the next day by 3 o'clock. All right, so I'm going to go on. So I'm going to do 1 or 2 of these with you So what we're going to be talking about is how to actually write an equation. So there's two ways to write an equation. There's more than two ways, but the two ways that we're going to be focusing on are slope-intercept form and point-slope form. So make sure that you guys write those two down. We're not using them yet, but we will use them on the next slide. Now, I'm going to do number one with you guys. Then you're going to do 2, 3, and 4 on your own. Some of you guys, I know you've already got this. But again, I just want to make sure that we clarify anything else. So I want you to find the slope that connects the 2 points. So find the slope of the line that connects these two. Now, I know that in any ordered pair, the first one is an X and the second one's a Y. The first one's an X, the second one's a Y. Where in the world do these 1s and 2s come from, and how are you supposed to know? It does not matter. And I say it does not matter, meaning if I want to say that this is my first point, then that becomes my first X and my first Y. This is my second point. This becomes my second X and my second Y. Well, guess what? What if I had a number like this, -4, -7? Well, that would be my third X and my third Y. So that's all those subscripts mean. It's identifying which ordered pair it goes to. Now, I'm going to get rid of all of that. And somebody's going to say, well, what if I want to call the first one? What if I want to say that this is the first point I see? Well, that's fine. Then that's your X1, Y1, and that's your X2, Y2. That's fine. What you can't have is this be my X1 and my Y2. So this is saying that's my first point, that's my second point. Now, it is difference of the Y's. I don't care which way you go. I've just said I don't care which way you go. So I always tend to go this way. So if I go 1 minus 5 over difference of my X's, that means I subtract. So difference of my X's, and here's where people tend to make a mistake. Difference 7 minus that other X is -3. 1 minus 5 is -4. 7 minus -3. We don't ever use double signs, so minus and negative is really plus a positive. And my slope is -4/10. I don't just keep it like that. You have to reduce. And that's your answer for number 1. Now, again, I'm going to give you guys about a minute and a half here, about 30 seconds per problem. Find the slope for 2, 3, and 4. Do it on your own. All right, I'm going to go ahead and start to put some of this up. I know a lot of you guys are still working, but the first one All right. Now, we're not finished here, but does anybody have any questions about the work that I've done? So I went ahead and found it for 2, 3, and 4. The slope for number 2, again, a negative over a negative is a positive, so positive 2/3. On number 3, be careful. Some people will just put a minus sign here no matter what, but it is -3 minus -3. Minus a negative is really plus a positive. So I've got 0 over -3. And number 4, it's -2 minus 2, which is -4, over 1 minus 1, which is 0. Any questions? All right, so we're not finished yet, because here's what I want you to see. 0 over -3, why that's not wrong, that's right. We don't ever say 0 over anything else. If 0 is ever on top, or in other words, if my y values are the same, my slope is just 0. So that would make a horizontal line. On number 4, anytime I have a number over 0, if 0 is underneath, it's undefined. So this would be a vertical line straight up and down, and my slope is undefined. So I want to start seeing your work here. But if it's 0 on top, your slope is 0. If it's 0 on the bottom, it's undefined. Questions? All right. Now, like I said, we're going to be using these two equations. I'll come back to them, but make sure you have written them down. So now I want you to write the equation of the line in slope-intercept form that goes through the point with the given slope. I want you to write your answer in slope-intercept form. That means my final answer should be y all by itself equals mx plus b. At the very least, you should be familiar with that. Remember, m is your slope, and b is your y-intercept, which is why it's called slope-intercept form. However, if they give us a point and a slope, I can use point-slope form. Point-slope form just says this. That's what point-slope form is. Why is that point-slope form? Because if they give you a point and a slope, you are literally plugging in for your x1, your y1, that point. This is the first x and the first y that they gave you, and this is your slope. It is all plug and chug. So you're going to do some of this here in just a minute on your own. I'm going to walk you through these. Well, you'll do number 2 on your own. But number 1, the first thing I have to do, that y stays the same, and it is minus my y1, but minus -4 is +4. So what these really mean are they're going to go in as the opposite of whatever you see up here. My slope is -3x minus x1, so x minus 2. Again, I don't think that's going to take you guys a lot of practice. I only gave you one more to practice, but I'm not finished because it said to write the equation in slope-intercept form. All that means is you have to distribute and solve for y. Then how do I solve for y? My last step would be to subtract 4. And you're finished. Again, I'm going to give you guys about 90 seconds here. Go ahead and try number 2 on your own. Just to save time, I'm going to go ahead and do a step at a time. There's the first step. Check your work. All right, so the last step, if you guys, whether you're finished or not, if you would pay attention to this real quick. So I put a fraction here on purpose. I know a lot of us are not good with fractions. We see a fraction and we kind of panic. You're gonna see a lot of fractions, but I promise you, especially when we get in person, I can see your work. You will be good at these. I can explain these. I actually kind of enjoy working with the fractions. So when I multiply it out, when I distribute it, well, I still have y minus 1 on the left side, and 2/5 times x is just 2/5 x. When I multiply a fraction by a whole number, I only multiply by the top and divide by the bottom. So 2 times 5 is 10, divided by 5 is just 2. Again, how do I do that? Anytime I have a fraction and I'm distributing, it's times the top divided by the bottom. My last step is plus 1. So my entire equation is, and you're finished. Questions? All right. We are almost finished for today. Not quite, but almost. Now, this is the, yeah. We've got these 4 problems and we're done. So write the equation of the line in slope-intercept form that goes through the 2 points. This is putting all of that together. Your first step is find your slope. So finding my slope, I know that my slope is going to be y2 minus y1 over 2 minus 1. So my slope is going to be -2 over 1. And we don't really keep it over 1. So my slope is really just -2. Second is you choose a point. So by choosing a point, I do not care which one of these you work with. It doesn't matter at all. You can pick the first one, you can pick the second one. It really doesn't matter. I always pick the ones with the smaller numbers. By smaller numbers, the ones that I prefer to work with, closest to 0. So I chose these, which makes this my x1 and my y1. Your third step is write your equation, point slope form. So that's what we did on the last screen. So I know my slope, I know my point. So y minus y1, so minus -3 equals my m times x minus 1. And then your last step is to convert to slope-intercept form. So again, all of this stuff, I know I'm going kind of fast. So if you have a question, please slow me down. But this is all just a review from Algebra 1. Distribute. And -2 times -1 is +2. Subtract. and you're finished. I know I just said we were going to do those other 2 questions. Let's do this last one. Make sure you can get this on your own. And then we'll be done for the day. You have no homework for tonight, except if you did not do those first 2 homeworks, or either one of those first 2 homeworks. Get those done tonight. Next week, I'm not going to have quite the same grace as I am this week. I know we're ironing out all the kinks. In about 30 seconds, I'll start going over this. All right. So first step, find your slope. And I will do my slope is 1 minus 2 over -2 plus 4. And I found that my slope was -1/2. Pick a point. I know I said I always pick the ones with the smaller numbers, but I'm going to pick this one just in case. Doesn't really matter. So y minus y1 equals m times the quantity of x minus x1. Again, change the sign, distribute. -1/2 times 4. -1 times 4 is -4 divided by 2 is -2. Then add 2. My final answer for this one is this. Now, part of the reason I put this up here is to show you I do not have to write +0 or -0. That's it. So if and when we start graphing and I don't see the y-intercept, it is 0. Now, does anybody have any questions at all? Let me open up the chat, see where we are. Yeah, somebody said they might not have their calculator until Tuesday. If you don't have a calculator and we start using it, the good news is all of these lessons are recorded, so you can go back and do that. So anybody that still doesn't have that, again, if you don't know if you will ever be able to get a calculator and you might need some assistance, please privately message me or email me and I'll see what we can do, okay? Last chance. Any questions? All right. Make sure that you understood what we did today. Tomorrow, we're going to move on to the graphs, but we need everything we just did. You guys have been a wonderful audience. I can't wait to see you guys in person so I can actually put some personality in this instead of just doing math. So you guys have a wonderful day. We are finished. Have a great day, guys.